So next, actually, we will be discussing on unit step sequence. So in the unit step sequence, right? Basically, like we have it's same as your u of t, but here at 0, like in the u of t, I discussed the value, mathematical value is half, right? But here, everywhere from 0 and above, you'll have the value as 1, the discrete sample.
Yes, sir.
So u of n equals to 1 equals to when n is greater than or equals to 0, else 0. This is unit step sequence.
Yes, sir.
And unit impulse. So here it is 1. Actually, in the continuous time signal, I mentioned it is infinity. Area is 1, right? But here delta of when n, right? Whenever I'm considering the unit step impulse, this is 1.
Yes,
Okay.
sir.
Just when n is 0, it is 1, else it is 0. And delta of n equals to, so this is also one of the important formula exam point of view, u of n minus u of n minus 1. So based on this, like you will have like various problems also. In the sense, what we do, you have u of n is this one, right? U of n minus 1 is actually 1 right shifted, correct?
Yes, sir.
This is u of n minus 1. When you negate this, only impulse function is going to be output. Okay.
Yes, sir.
So actually, in case of continuous signal, u of t is nothing but integration from minus infinity to t delta of t dt, right? That's what we saw, because like the differentiation of you like differentiation of u of t is going to be like differentiation of u of t is delta of t, correct? So then
Yes,
integration
sir.
of
Yes,
delta
sir.
of t is u of t. So
Yes, sir.
in
Yes,
case of
sir.
like when it comes to your discrete signal u of n, so wherever integration is there, just add the summation. Basically here, like we are adding the discrete signal, right? M equals to minus infinity to 0 delta of n minus n. So you'll have one delta. So I mean, the physical meaning of it is actually you'll have one delta. What you will do, every time you shift one, add it. Shift one, add it. So when you do this,
Yes,
you're
sir.
going to get u of n. Okay.
Yes, sir.
And one more important thing, delta of kn, kn is actually it's delta of n. So if you scale that also, it is going to be original signal delta of n. So for example, if someone say delta of 4n is nothing but
Yes, sir.
delta of n only. From signal, if you want to understand this physical meaning, so delta of n is 1. So if I try to get like delta of 4 and 5, 6, anything, if I scale also, it is going to be at the origin itself, right? So that's why delta of
Yes, sir.
kn is actually delta of n. Okay. Then some of the transformation of the signal is also very important. So you will be getting many questions on also. I mean, in terms of PGCET, it might be one, but it's a for sure questions, right? Transformation.
Yes, sir.
So first one is time scaling.
Yeah.
So x of t, like if I scale it in time domain, x of at.
Yes, sir.
It is something like, especially you have seen that in YouTube and all, when you speed up the voice, right? So we are actually doubling the time. Basically, we will be skipping some of the points, right? So same way,
Yes, sir.
x of time shift, x of t minus t naught is actually we'll be giving the delay. I mean, whether we are shifting right or shifting left, so on. Correct? So it's a
Yes.
propagation delay. Then time reversal, we basically negate the time x of minus t. Like we'll be changing the direction like in this way. Correct? X of minus t.
Yes, sir. Correct.
Same way, we have amplitude scaling. In the sense, if I have x of t, where I can scale it by factor
X of
k.
t.
Right. I can scale it by factor of k. Then what will happen? For example, if I have one rectangle signal, x of t
Yes,
is
sir.
rectangle signal. Rectangle signal of amplitude 1, then when I scale it, it is going to be amplitude k, right? It's a multiplication of the signal, straightforward, right? Time scale. It's amplitude scaling. One we saw is time scaling, right? Previously, it is amplitude scaling, right? So coming to the problems, okay? So if someone give you this is x of t, it starts from -1 to +1, okay? So then if someone asks you to scale it, x of 2t, so what is going to be your time axis?
So x of 2t is divided by 2 will become compressed.
Yes. So it will become 1 by 2
2 and 1 by minus 1 by 2.
You have to divide by, right? X
Yeah.
of 2t.
Yes, sir.
So if someone asks you x of t by 5, then you have to actually increase the time axis.
Increase it will get what I can say
plus 5.
expand.
Yes. Then from -5 to +5. This is
Yes,
so
sir.
actually in general, so you will get some multiple choice question like this also. Whenever we are scaling, if a is greater than 1, like if I have to scale like x of a t, if a is greater than 1, then it is compression, correct? Compression.
Yes, sir.
If a is less than 1, then it is expansion.
Yes, sir.
Right? So same way, if someone asks you to time shift x of t minus 2, then what you have to do, basically you're going to shift it by right side, right? So by position of 2, from -1 it will come to 0 and 1. So it will start from 1, 2, 3, x of t, correct?
Yes, sir.
And same way, if t naught is less than 0, x of t plus 2, if I say, then if it is t plus 2, then we have to left shift by 2. It starts from -1, then -3, correct?
Yes, sir. Yes, sir.
Yeah. So there are some examples also, like in terms of one of the problematic question I can take, like which is from gate. So they have given like u of t plus 1 minus 2u plus u of t minus 1. So we have to find the y of t. So they have given various options in terms of waveforms, which is the correct waveform. So how to do that? First, like we have to give u of t plus 1, right? So how it is actually starts from minus 1. We have to shift left, right? U of t plus 1 is this, correct?
Yes, sir. Yes, sir.
U of t plus 1. So what is 2u of t? So it starts from 0 itself, but it goes up to 2, right? So this is 1.
Yes, sir.
2, correct? Then 2u of t minus 1. T minus 1 is actually here, right? Here.
Yes, sir.
At what point it starts? So this is at minus 1. So it is at plus 1, correct? So first,
Yes, sir.
if I add, okay. So first, let me just write this one. U of t plus 1 minus 2u of t. Right. So what happens? So here it is as it is, right? So this is as it is. And from here onwards, it is plus 1 minus 2. So here onwards, you are going to get minus 1. Correct? Plus 1
Yes, sir.
minus 1. So only this one. Because u of t minus 2u of t. So this one is as it is. Here you are going to get minus 1 because this is 1, this is 2. 1 minus 2, it is going to be minus 1. This you are clear,
Yes, sir.
right?
I'm clear,
Now,
sir.
now I have to add it.
Hmm.
Now if I add it, what is going to happen? So this is like final adding u of t minus 1. So you're going to get this signal followed by here minus 1 will be as it is because minus 1 plus 0, it is minus 1. Then rest of the things will be get cancelled. So minus 1 plus 1. Clear, right?
Yes, sir.
One ramp based also one example I will take. Ramp based question. Then we will move on to next topic.
Yes, sir.
So next question is y of t equals to r of t plus 2 minus r of t plus 1 minus r of t minus 1 plus r of t minus 2. This is the question. So you know that r is nothing but ramp, right? So ramp which starts at r of t is ramp which starts at origin.
Yes,
Correct?
sir.
So r of
Yes, sir.
t plus 2, what will happen? Your ramp starts at minus 2.
2. Yes, sir.
Minus 2.
Minus 2. Yeah. Correct.
R of t minus t plus 1. Your ramp starts
It's
at
minus 1. It starts from minus 1.
minus. Minus. So another is r of t minus 1, which starts at plus 1.
Plus 1. Correct.
R of t minus 1 and r of t minus 2, which starts at 2. Correct?
Yes,
Ramp
sir.
starts at 2. So now, if first we will do this part. Okay, r of t plus 2, r of t plus 1. So at minus 2, only this one starts, right? So if you see from minus 2 to minus 1, there is nothing, only this part, right? So minus 2 to minus 1, so there is a ramp. Because when
Yeah.
if I subtract anything, nothing is there, right? Everything is subtraction and addition. So from minus 2 to minus 1, nothing is there, right? So this is next point is this minus 1. Till minus 1, nothing I have. So it starts at minus 2. Till minus 1, I don't have anything. So I will draw a ramp. Then what I
Yes.
am doing, I am subtracting this ramp, right? From minus 2 to minus 1 to 0, I am subtracting this ramp, correct?
Yes, sir.
Because from -1 you have another run. So when I am subtracting this slope, then whatever I'm going to get, that is a constant slope, 1, 0, right? Straight line.
Yes,
Till
sir.
what point? Till 1 point, till 1 I don't have anything. But after 1, what I have? After 1 I am subtracting this part, right? So this is at -1.
Yes, sir.
So I'm subtracting this.
Yes, sir. Yes, sir.
Then after 2 I'm adding. So then whenever I'm adding, so subtraction minus negative slope is there. When I add another positive slope, it will become again constant.
Mm-hmm.
Correct? So -1
Yes, sir.
+1 +2. So you're going to get this trapezoidal. Okay?
Yes, sir.
Clear, right?
Yes, sir. Yes, sir. Yeah.
Okay. You can take one problem as assignment. Like if you have any doubt, maybe like we can discuss tomorrow that problem.
I got it, sir. I got it.
Okay. You can take just one problem as a home. You can just
Yeah,
try.
sure. I can take it. No issues.
Yeah. T plus 4. R of
Just
y of t equals to R of t
yes, sir.
plus 4
Okay.
minus R of t plus 2 plus u of t minus 3 R of t minus 4 plus 3 R of t minus 5.
Yes, sir.
Okay.
Yes, sir. I wrote the
Okay.
question. Yeah.
Okay. Next important concept, a power signal, power and energy signal. Okay, that is also very important concept in terms of your competitive exam point of view. Power and energy signal. Okay. So first, power signal. If average power of a signal is finite, then we call that signal as power signal. If the average power of signal is finite, then we call it as power signal. So how to find P average? So P average in time domain is given by limit t tends to infinity 1 by 2t from integration minus t to plus t x of t whole square dt. So if you get any signal, right? So if this is a finite value, if it is not infinite, then you call that signal as power signal. So usually in exam, how they'll give you x of t. So they'll ask you to find whether it's a power signal or energy signal. So you have to do this. Like first you have to integrate over a period. Then you have to substitute like t is minus infinity. So if you get some finite value, not
Yes, sir.
infinite, then it's a power value. Same way for the discrete signal, limit n tends to infinity 1 by 2n plus 1 sigma n equals to minus n to plus n sigma x of n whole square. Okay.
Yes, sir.
Next is actually if the average energy of the signal is final, right?
Yes, sir.
Then that is called energy signal. Okay. So
Yes, sir.
basically here also limit, if you see the value we have taken from minus t to plus t over a single period, right? But actually for the energy signal, what we do, from minus infinity to plus infinity, okay, or like 0 to infinity we take. Okay. Then uh, if that signal is the amplitude is 0, the energy is 0. Okay? So the basically the condition is t tends to plus or minus infinity. Okay. And amplitude, okay, amplitude is 0. That is like overall energy is 0, right? Then like we call it as
Yes, sir.
energy signal. Okay. So in the sense, I mean, in terms of p average, right? I mean, if you want to compute, so if you want to take this
Yes, sir. Yes.
example itself, okay, so
Yes,
here
sir.
some finite value you get, but if you get
Yes,
p
sir.
average 0, p average 0, then obviously it will be our energy signal. If p average is some finite value or infinite, then it is power signal. But if this
Yes, sir.
whole thing becomes 0, then it will become energy signal. Okay,
Hmm.
clear, right?
It's clear, sir. Yeah.
Okay. So all one more important point: all periodic signal, right? Periodic signal,
All periodic signals are not energy signals.
yes.
Hmm.
What about complex sinusoid? That is a power signal,
Hmm.
sinusoidal signal. Okay.
Yes, sir.
Next important thing is a even and odd signal.
Yes, sir.
So if x of t equals to x of minus t, then it is even signal. If x of t equals to minus x of t, x of minus t equals to minus x of t, then it is odd signal. I mean, this is like
Yes,
very
sir.
straightforward thing. So I mean, like I'm not going to take any uh, problems as such. Okay.
Yes, sir. Yeah.
And there are actually few more types of signal, that is like conjugate signal. So this is like especially in gate, this is very important concept: conjugate, complex conjugate, and conjugate signal. Even like nowadays they ask in the PGCET also,
Yes, sir.
conjugate signal. So for example, if I have x of t equals to at plus j bt, okay. So we call it as an even conjugate if x of t equals to x star of minus t.
Yes, sir.
Even conjugate.
Yes, sir.
Odd conjugate, whenever I say conjugate, what we have to do? We have to, like wherever complex signal is there, you have to take minus of that, right? Minus j of b of t, right? See, complex
Yes,
signal,
sir.
j of bt's complex signal is minus j of bt, right?
Yes, sir. Yes, sir.
So this is first condition. This is the condition for even conjugate. For odd conjugate, x of t is minus x star of minus t.
Yes, sir.
Okay. So I'll give you one problem. So x of t equals to t square of e power j omega t. whether it is a even conjugate or odd conjugate. They will ask these kind of questions. Find so they will ask like, is it a even signal, odd signal, even conjugate signal, odd conjugate signal? That kind of options. Okay. Can you try this?
So I guess this is an even conjugate signal.
What is the reason? What is x star of t? X star of t? It is nothing but x star of t is t square e power minus j omega t. Correct?
So
But it is not same. But x star of minus t will become t square e power plus j omega t. That is same as x of t. Correct?
yes, sir. Yes, sir.
This is even conjugate.
Yes, sir.
There is a shortcut formula. So the people will ask, find the even term and odd term. Okay, odd term and even term. So the easy formula for even term x e of t is same as x of t plus x of minus t by 2. If someone asks you to find the odd term of a signal, x odd of t is x of t minus x of minus t by 2. This is the odd terms.
Yes, sir.
So, do you know how to find the period of the signal? You want me to explain that?
Sir, I know that, sir. Yeah.
Can I skip that?
Yes, sir, you can skip that without fail.
Okay. What about the properties of systems?
Properties of system also you can skip it, sir. I know about that. But I have doubt on Fourier transformation. Fourier transformation is which I required. So Z transform also I know some parts of things. But yeah.
Okay, okay, okay. Okay,
I
then
guess Fourier transformation, that correlation and convolution and Fourier series and transform, those things I still have a confusion with.
okay, 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 okay. Okay, then we can start from that also. Okay,
Yes, sir.
we can straight away jump into that Fourier transformation in Fourier series. So, we'll start with Fourier series.
Mhm.
Okay, so the Fourier series. So, for example, if you have a sinusoidal signal,
Mhm.
it is of one frequency, right? I mean, in terms of frequency, whenever I say this is of one frequency, f naught, right? F naught, or
Yes,
like
sir.
f1, f2, f3. But as per Fourier series, any signal, consider any signal, square wave, triangular wave, or rectangular wave. So any signal is nothing but it can be constructed as sum of these sinusoids. Like, for example, square wave, if I consider, it is something like you have this signal. This is one, this we call it as fundamental frequency. Then you may be adding some higher frequency term with a different amplitude. So you consider like A0 with some sine AT plus B0 times sine BT, so on, right? So whatever the like,
Sure.
and again, like some cost terms also. So A0, A1 sin BT, so on, and B0 cos AT, B0 cos PT, B0 cos CT, so on. So we'll be adding various sinusoids, right? Like even or some DC terms. So we add those terms and we construct the corresponding signal, like it can be a triangular wave or sine wave, like anything. So that construction, right, we basically represent by a Fourier series. Fourier series.
Yes, sir.
Okay. So how we are able to construct those basic signals, right? And as you know, each frequency of the sinusoidal signal is a orthogonal signal. I mean, like it is independent of each. Okay? So that is where when we add this orthogonal signal, right, we are able to uh, generate those triangular wave or rectangular wave. And I mean, if you had seen this sinusoidal, I mean, the triangular wave in a frequency analyzer, right? So you'll be seeing like various frequencies. The triangular wave is not a single frequency signal; it is made up of different sinusoidal waves. Okay, and we have, like, when we say Fourier series, Fourier transform, there are like various types of Fourier transform series you might have, right? So continuous time, this DTFT, CTFT, DFS, CFS, right? So it is purely based on how you express time and frequency. Okay, if the time is continuous and frequency also continuous, okay, time and frequency both are continuous, then we deal with continuous time Fourier transform. So this is also one of the questions they have asked. So like time is continuous, frequency is continuous, which Fourier method you are going to use? So time is discrete. The time is discrete. Frequency is continuous. Then we are using discrete time Fourier transform. The time
Yes,
is
sir.
continuous, frequency is discrete. We are going to use continuous Fourier series. So here it was transform. Here we are using series. If the time is also discrete, frequency also discrete, then we are using discrete Fourier series or DFT.
Yes, sir.
Okay.
Yes, sir. Correct.
Okay. So anyway, now this meeting will end. But like tomorrow onwards, we will discuss like various problems on this DTFT, CTFT, all this stuff. Okay. So I mean,
Yes, sir.
then I'll majorly focus on this Fourier transform, Fourier series, and Z transform, because like you, as you said, like other stuffs are like you're familiar with.
Yes, sir.
And then we will take up some question paper problems.
Yes, sir. Okay.
Okay. Thank you. So tomorrow morning you will be
Okay.
attending the session, right?
Morning at what time, sir?
7 a.m.